Good Science. This is Mr. B, and we're continuing with our outer solar system here. Again, we're going to talk about the other three gas giants today. So the first gas giant, again, we left off with Jupiter last time, is Saturn. Again, the big thing about Saturn are the rings. Again, they have the largest rings, and they're most visible from Earth. Saturn also is the second largest planet in our solar system, right behind Jupiter, and it is in fact best known for its rings. The rings are made of particles of ice and ice-coated rock. And these particles are generally between a few micrometers and could be as much as 10 meters across, with most particles within that being snowball size. And the rings are about 274,000 kilometers in diameter, yet they're only tens of meters thick. So again, diameter, measure the distance across there. But again, if you look at the thickness level, they're not very thick at all. So that's kind of just some of the, I don't know, I think it's kind of crazy to think there can be something that is that immense in length there. Again, if I had to kind of make it similar, the diameter is so large, but yet it's only really thin. So that is kind of one of the more interesting thing about Saturn. Again, its rings are its defining feature there. And for the atmosphere, again, it has colorful banding in the atmosphere. Again, those different cloud patterns moving at different speeds. Its atmosphere is the largest of any planet in the solar system, and it also has the lowest average density, which is less than the density of liquid water. So again, we talked about how, again, if you try to land something on there, there's no solid surface to land on. Again, Saturn, between that, or between all those gas giants, has the least dense gas land on. Again, it's less than the density of liquid water. And its atmosphere is made mostly of hydrogen and helium, again with small amounts of other elements. Again, that's the defining feature of those gas giants is their atmospheres being composed of mostly hydrogen and helium. Again, so here's the picture again of those ice and ice-coated rock particles. Again, 274,000 kilometers in diameter, but only tens of meters thick. But again, it's a very spectacular image. Again, the defining feature there of Saturn is its rings. There are a bunch of moons, again, not quite as many that are present or orbiting Jupiter, but there are 56 moons orbiting Saturn. Again, most of those are very small. Their largest moon and kind of their most famous moon is one called Titan. So that'd probably be the moon of Saturn that you need to know. The Titan is larger than Mercury, and it is the only planetary moon that actually has its own thick atmosphere. So again, it is the size of a small planet. Again, and it does contain an atmosphere as well. So that's kind of that's Saturn's moon claim to fame there is Titan. So that's Saturn. Again, went through that quickly. Again, big thing, the rings. Again, the moon Titan that has the atmosphere. And then there's Uranus. And the big thing about Uranus is that its rotation is tilted more than 90 degrees on its axis. So we're going to see a picture of that, and that'll probably do a little bit of better explanation about its unique characteristic there. Again, gas giant. Again, our next one now, I think we're at what our seventh solar. Yeah, so we had Mercury, Venus, Earth, Mars, Jupiter, Saturn. Now we have Uranus, and because it is so far from the sun, it is very cold. Again, another atmosphere mostly made of hydrogen and helium. Again, very characteristic of the other gas giants. But one thing that's new about Uranus that you would probably need to write down is the large amount of methane that it has. And because of this, it gives it a distinct blue-green appearance. So that is kind of its own unique feature that it has compared to the other gas giants, is the presence of methane, which gives it its blue-green appearance. And then also, like the other ones, it has a very dense core, but their core kind of has some other kind of interesting things going on there. It's thought to be surrounded by a thick mantle layer of liquid water and dissolved ammonia, and then as well as a layer of liquid hydrogen and helium surrounding the mantle. So they have a very interesting, unique structure there on Uranus as well that kind of makes it, again, another unique characteristic there. Again, they also have rings. Again, they're not as visible as Saturn. And they also have at least 27 moons, although there's really not, most of them are large enough to really have any claims to fame there surrounding Uranus. Again, it's big kind of thing, again, that has the methane, it has the interesting kind of core and mantle, but the most unusual characteristic of Uranus is that it lies nearly on its side. So Earth, we have an axis that we're slightly tilted on, but Uranus's axis, it's like completely almost knocked over, which you'll see a picture here in a moment that'll kind of help it make a little bit more sense. So it rotates in a direction opposite to the direction of its revolution around the sun, and its rings and moons revolve about the same tilted axis. So its revolution is even kind of messed up. So it spins one way on its axis, but then the whole planet itself revolves around the sun in the opposite direction. So again, that's kind of hard to kind of explain over a video. So I will make sure I explain that more in class. And again, okay, there's the picture coming up here in a moment. Again, their northern and southern hemispheres, because it's tilted in such a way, alternate being exposed to the sun for many years. So one northern hemisphere will be exposed to the sun for many years, then it kind of rotates and revolves around the sun. Then the other one will be exposed to the sun for many years. And this constant heating and cooling can cause immense storms. And then to give an explanation as to why it is tilted in this way and why it behaves that way, no one really knows for sure why it is so tilted. Kind of the most generally accepted hypothesis is that early on, another large planetary body might have collided with Uranus that caused it to shift in such a manner to be tilted on its axis. But that's really the best explanation that we have as to why that tilt happened the way that it did. So again, here is the axis, to where if this was Earth, these two poles right here, one would be all the way up here, the other one would be all the way down here. So the axis is almost tilted 90 degrees. So that kind of gives you an idea. And then again, it's spinning one way, but then the way that it spins is the opposite way that it revolves around the sun. So its rotation is opposite its revolution. And like I said, I know it's kind of hard to explain, but this picture might help you visualize it a little bit more. So again, that's the big thing for Uranus that you need to know, that it's tilted on its axis so greatly there. The last gas giant that we'll end this video with is Neptune. So Neptune's bluish color comes from the amount of methane in its atmosphere. So again, similar to Uranus there, kind of another methane planet here. And Neptune is so far from the sun, again moving out, again the 8th one now, that it takes a very long time, 165 Earth years to be exact, for it to make one revolution around the sun. So that's again a very, very long time. 165 Earth years equals 1 year in Neptune, and it has about the same size, about the same composition, and is about the same size as Uranus. So again, some of those features that we just mentioned about Uranus will also apply to Neptune as well. One thing about Neptune it does that's kind of a little bit different, it just has clearly visible cloud patterns in its atmosphere. They're very thin, they're very wispy clouds. Again, thin and wispy, I don't know a better word for wispy than thin. So very light clouds that form high in their atmosphere, and they are in fact made of methane ice crystals. So again, our clouds are made of condensed water, their clouds are made up of crystals of methane. Again, because of this, they also have large storms in their atmosphere. There was one storm that was observed by the Voyager 2 space probe in 1989, and it was called the Great Dark Spot. But by 1994, the storm was gone, so we don't know if it was gone completely, or again, it could have just kind of fizzled out, unlike the Great Red Spot that is on Jupiter, which is still there. So this storm, again, must not have been quite as powerful as the one on Jupiter, or we just just went to an area where maybe we couldn't see it. But I'm guessing by 1994 the storm no longer existed. And so here again, here's our great dark spot right here in the center. Again, another storm that was similar to the size of Earth, again taken in 1989, but by 1994 it was in fact gone. So again, great dark spot, another storm similar to the red spot of Jupiter. And then Neptune does have thin rings, very similar to that of Uranus as well, and they have at least 13 moons. Triton is the only large moon, and it has a thin atmosphere as well as an icy surface. So again, that is it for all 4 of our gas giants now. Let me know if you have any questions.